Okay, everybody, we are going to be looking at, well, this is chapter 3, section 4. We're going to be looking at writing a function rule. So you've been looking at how the similarities between what is a function rule versus what is an equation. Kind of what we're coming to is that fundamentally or structurally, they're pretty much the same, except instead of a y, you use an f of x. And that there's the rule about for every input, there's exactly one output when it comes to a function. Well, let's say what we're going to do is we're going to start with writing a function rule from a table. So I've got this table right here. It's got x, or the inputs, and then you've got f of x, which is your output. Now, if you don't like f of x, just remember that this is also known as y. Okay, so if you don't like f of x, think of it as y. So if I put 1 in, I get 5 out. If I put 3 in, I get 11 out. 5 in, 17 out. 7 in, 23 out. So I want to take this information and write an equation. Well, this is a linear, so we're working with linear equations. And let's remember that in equation form, we have y equals mx plus b. Okay, where m is equal to the change in y values over the change in x values. Or in this case, it's the change in f of x values over the change in x values. And this information to figure out slope is included in this table. So let's go find it. Let's start with, here we go. We'll start with the x side. So the change in x value is consistently 2 every time. From 1 to 3 is 2, from 3 to 5 is 2, from 5 to 7 is 2. So that's a good consistent change we've got going on there for delta x, change in x. On the other side, delta y, or delta f of x if you like, is a consistent plus 6. So I can come over here and find the slope, well, let's use the right color pen. Slope, which is delta y over delta x, from this table is 6 over 2 is 3. So the rate of change is 3, all right? And if we were graphing it, it would have a slope of 3. So we're halfway there. We've got the m, now we just need the b, all right? Well, b, the y-intercept, happens when x is 0. The problem is we don't have that in the table. We don't have 0 as an input, but we can extrapolate that. So I'll put it in here, it's in blue, and if I count backwards, 7 minus 2 is 5, 5 minus 2 is 3, 3 minus 2 is 1, and 1 minus, now see the change there is a little bit different. The change from 1 to 0 is half of what was going on here. And I need to keep that in mind because over here I'm going to need to worry about that. See, 23 minus 6 is 17. 17 minus 6 is 11. 11 minus 6 is 5. Now, because I was going half as much over here, I'm going to go half as much here and just do 3. So 5 minus 3 is 2. And there, that is my b. But you have to be, can you see that there? You have to be careful that when you're counting up, if you're doing half as much here to get to 0, you have to do half as much over here. In any case, I now know that b equals 0. So I can write the equation for this as y equals m is 3, x plus, wait, where'd the 0 come from? That's totally wrong. The b is 2. That was a stupid mistake, but I'm glad I caught it. And then I can finish it. 3x plus 2. Now that's in equation form. Function form, it would be f of x equals 3x plus 2. So there is how you get the function rule or the equation from a table of data. Now, if we wanted to apply this, let's look at the next question. This question is built around context. Write a function for total distance, so d of h, traveled after h hours at a constant speed. So the distance is a function of h, and that's why I'm using d and h instead of f and x. D is distance, h is hours. Write a function for total distance traveled after h hours at a constant speed of 45 miles per hour. Okay, so d of h equals, I can still use mx plus b, okay? So that's the slope-intercept form. Now I'm going to come over here to the table. Now just use logic. If I go for 1 hour at 45 miles per hour, I'm going to cover 45 miles. If I go 2 hours at 45 miles per hour, I'm going to cover 90 miles. And if I go for 3 hours at 45 miles per hour, I'm going to cover 135 miles. Okay, so my change in x values, my delta x is 1, and my delta y equals 45. So I can put those in for my slope, because remember, slope is delta y over delta x. So I'll put that down. That's 45 over 1 times x plus, now the b, come over here. I don't have 0, right? So I need to put 0 in. But hey, you know, you can count backwards or you can use logic. If you go for 0 hours at 45 miles per hour, how far do you go? Well, you're going for 0 hours. You don't go at all. So that is 0. So my b is 0. I simplify this. D of h, the distance as a function of time, equals 45 times, h. I'm going to put h. I should have been using h here instead of x. Anyway, you get the idea. So this is the function of how far you would travel for h hours of traveling at 45 miles per hour. Look, it's a very simple concept. We're just making it more complicated. Logically, it makes sense. Because you go for 1 hour, you go 45 miles. You go for 2 hours, you go 90. You go for 3, you go 135, and so on. So that actually makes a lot of sense. I would like to squeeze one more problem into this video. Just another straightforward function one, just to make sure we've got some practice on that. So I'm going to take that page away and just do one more example. All right. So here's my table. I've got x, f of x. Always use a straight edge. Okay, this is the information you're going to be given. You've got 2, 5. So when 2 is the input, you get 5 out. Then 4, 9. 6, 13. And 8, 17. Okay, so y equals mx plus b. Again, remember, instead of y, you can use f of x. And matter of fact, when I do my final answer, I'll be using f of x because we are in functions. Delta x equals 2, and that's consistent. 2 to 4, 4 to 6, 6 to 8, they're all 2. And my change in y, delta y, equals 4. And again, that's consistent. 5 to 9 is 4, 9 to 13 is 4, 13 to 17 is 4. So y equals delta y, which is 4, over delta x, which is 2. Remember, m equals delta y, change in y over change in x. X plus, we're going to have to go back to the table and put in a 0. Now, this time, 8 minus 2 is 6, 6 minus 2 is 4, 4 minus 2 is 2, and 2 minus 2 is 0. So it's consistent change here, so I don't have to modify anything over here. 17 minus 4 is 13, 13 minus 4 is 9, 9 minus 4 is 5, and 5 minus 4 is 1. So that's my b value, so I can put 1. Okay, let's simplify it. Y equals 2x plus 1. And now let's write it as a function. F of x equals 2x plus 1. So I've just given you two examples on how to take a table of information and write the function rule or equation that goes with the data. And I also did just a very simple context problem.